Hi teacher, my name is ch5 mtong. Today I will to present chapter 5 CPU scheduling. Okay, let's go. Outline a basic concept: scheduling criteria, scheduling algorithm, real-time CPU scheduling, operating system, example, algorithm, evaluation. Object describe various CPU scheduling algorithm, access CPU scheduling algorithm based on scheduling criteria. Describe various real-time scheduling algorithm. Describe the scheduling algorithm use the Windows, Linux, and Solaris operating system. Apply modeling and simulation to evaluate CPU scheduling algorithm. Basic concept คือ maximum CPU utilization alternate with multiprogramming CPU I/O bus cycle process execution consists of a cycle of CPU execution and I/O wait. CPU bus followed by I/O bus. CPU bus distribution is of main concern เนี่ย yes รูปนี้ครับการทำงานต่อไป histogram of CPU bus time less number of short bus small number of longer bus okay CPU scheduler The CPU scheduler selects from among two processes in ready queue and allocates a CPU core to one of them. Queue may be ordered in various ways. CPU scheduling decision may take place when a process switches from running to waiting state. I/O request switch from running to ready state. Interrupt switch from waiting to ready. Terminate. For solution 1 and 4, there is no choice in terms of scheduling a new process. Must be selected from execution from solution 2 and 3. However, there is a choice. Primitive and non-primitive scheduling. When scheduling takes place only under circumstance 1 and 4, the scheduling scheme is non-primitive. Otherwise, it is primitive. Under non-primitive scheduling, once the CPU has allocated to a process, the process keeps the CPU until it releases in either by terminating or by switching to the waiting state. With seclusion and rest condition, preemptive scheduling can result in rest condition when the data are shared among several processes. This issue will be explored in detail in chapter 6. Okay. This departure. Okay, departure model gives control of the CPU to the process selected by the CPU scheduler. This involves switching context, switching to user mode, jumping to the proper location in the user program. Dispatch latency time is taken for the dispatcher to stop one process and start another running. Okay. Scheduling criteria: CPU utilization, throughput, turnaround time, waiting time, response time. Okay. And as busy as possible, complete executive. Ready here, the first response. Scheduling algorithm optimization criteria: max, min, to max and 3 min. First come, first serve, scrolling, process, bus time, P1, 24, P2, 3, P3, 3 โอเค P1 โอเคนี่คือการทำงานของ first come first นะครับต่อไป first come first scrolling P2 P3 P1 shortest job first scrolling the length of its next CPU bus ch5 is the optimal give minimum average waiting time for a given set of processes. Example of ch5 process P1 6 P2 8 P3 7 P4 3 P4 3แล้วก็ P1 6 P3 7 P4 3 average waiting time 7 okay. Determining length of next CPU bus can only estimate of length should be similar to the previous one. Then pick process with the shortest predicted next CPU bus can be done by using the list of previous CPU bus using exponential averaging โอเคนะครับอันนี้ก็เป็นสูตรนะครับผม prediction of the length of the next CPU bus example of shortest remaining time first P1 arrive time O but time 8 P1 โอเค round robin each process get a small chunk of CPU time usually 10 to 100 milliseconds after this time has interrupted the process in the period and add to the end of the ready queue. If there are n processes in the ready queue and quantum timer interrupt every quantum to schedule next process. The sample of RR with the time quantum is 4 P1 24 P2 3 P3 3 time quantum and content switch time นี่คือการทำงานนะครับของรูปภาพนะ Turnaround time vary with the time quantum นี่คือรูปภาพของการทำงานนะครับผมตามนี้เลย Priority scheduling a priority number is associated with a process CPU allocated to the process with the highest priority preemptive non-preemptive example of priority scheduling โอเคก็ตามนี้ครับรูปภาพโอเค next priority scheduling round robin โอเคครับผม multi-level queue priority O priority 1 priority 2 priority n priority session based upon process type multi-level feedback queue a process can move between the various queues. Multi-level feedback queue scheduling defined by the following parameter. Example of the multi-level feedback queue. This queue QO Q1 Q2 scheduling a new process enter queue QO with server in RR. As ch1 job is again served in RR and receive 16 additional milliseconds. Real-time CPU scheduling can present a wide challenge. Solve real-time system no guarantee. Hard real-time system takes must be serviced by the deadline. Event latency, the amount of data is lapses from when an event occurs to when it is serviced. Type of the latency affect performance. Interrupt latency time from error of interrupt to start of routine that survive interrupt. Dispatch latency time for the scheduler to take current process of CPU and switch to another. Interrupt latency. Dispatch latency function of any process running in the kernel mode, released by low priority process of resources needed by high priority process. Priority-based scheduling for real-time scheduling, scheduler must support primitive priority-based scheduling, but only currently of real-time. For hard real-time also provide ability to meet deadline. Okay. Operating system example: Linux scheduling, Windows scheduling, Solaris scheduling. Linux scheduling version 2.5. Primitive priority-based. To priority length, time sharing, and real-time length for all tune 99 and nice value from 100 to 140. If no time left, expert not unable using or the test use their slide or run able test tag in per CPU run queue data structure. Windows scheduling. Windows use priority based primitive scheduling. Highest priority thread running. Dispatcher is scheduler. Variable class is 1 to 15. Real-time class is 16 to 31. Q4 is priority. If no runnable thread, run idle thread. So, list priority based scheduling, secretable time sharing, intelligent real-time system, fair, share, fixed priority system. Given thread can be in one class at a time. Each class has its own scheduling algorithm. Time sharing is multi-level feedback queue. Algorithm evaluation. How to select CPU scheduling algorithm for SOS. Determine criteria. The evaluate algorithm. Deterministic modeling. Type of analytics evaluation. Deterministic evaluation. For each algorithm, minimum average waiting time. Simple and fast, but require X number of input apply only to first input. Okay. Thank you, teacher. See you. Goodbye.